Good morning and welcome to today's TPC Tranco webinar, Controlling Maintenance Resources. Today we're going to get down and dirty with all things maintenance. We're going to talk a little bit about TPM, 5S, predictive maintenance, you name it. So we're scheduled for about an hour today. We'll take some questions and answers at the very end. So if you do have any questions, on the right-hand side of your webinar toolbar, you'll notice there's a little drop-down area for questions. Just type your question in there, and we'll get to them at the end of the presentation. The most common question we usually get, however, is, can I get a copy of the presentation? And that answer is absolutely yes. After this presentation, you'll receive a thank you email from us. Please just respond to that email that you would like a copy of the presentation, and I will get that out to you quickly. So, with that being said, I would like to turn it over to our presenter today, Brett Smith. Brett?
Good morning. Good morning, John. Morning, everybody. This is Brett Smith. I'm speaking from Chicago today. I hope everyone can hear my voice, and let's go ahead and jump into the webinar. Okay, there we are. Just a little bit of information about me. I do have a technical background. I started working in complex engineering operations and maintenance in the late 70s. I'm retired military. I worked for another 10 years as a contract manager and project engineer with Aramark Service Master. Did some work in their healthcare and education divisions. Spent a few more years working in production. And about 10 years ago, I joined what is now TPC Training Systems as one of their employee instructors. I've done about 350 of these seminars over the years, and we'll look forward to meeting any of you in those seminars sometime in the future if there's anything that we can do for you or your organization. A little bit about what TPC systems are. We have TPC Online, which is our computer-based training, consulting services where subject matter experts can visit your facility and provide you support that you have requested. TPC iSchematic is another one of our divisions where we can provide support for existing equipment and providing services to verify equipment line diagrams and make recommendations as to training as new equipment is brought into the facility or existing equipment needs to be evaluated. TPC Tranco, the group that I've been working with these many years, we do instructor-led training. That is public courses where we can meet and provide services to several different organizations simultaneously, and we also provide on-site training. So a request from your facility to have an instructor come in and present material to a group of your choosing that you would designate and a topic of your choice. So that's what we do in a nutshell. Today's webinar goals really is to discuss maintenance opportunities across the board. It really doesn't matter if you're in manufacturing, education, healthcare, whether you're working in a government-related organization or part of a nonprofit organization. You take those job descriptions away, we all have the same kinds of challenges. We are all dealing with maintaining our skill sets, complying with state, federal, and local regulations. We're all having to deal with skill set retention, any number of things. So we have a lot more in common when you come to one of our programs than you might think. As part of our TPM, Total Productive Manufacturing processes, the first thing I want to mention and emphasize is the need to identify critical equipment. And by that, I mean equipment that you must have up and operating to fulfill your contractual requirements and your service obligations. It's pretty obvious to me in many facilities that I visit, there is far and away too much maintenance, too much scheduled maintenance, too much maintenance requirements that have been recommended by the original equipment manufacturer. We often don't have the skill sets and the labor hours available to do everything that we would like. Therefore, we must prioritize. So think about the equipment that you must have available every day for you to fulfill your organizational goals and obligations. We talk about autonomous maintenance. Autonomous maintenance is assigning low-level maintenance tasks to equipment operators. And this is in no way demeaning. What I'm asking operators to do is just routine tasks such as visual inspections for lubrication leaks or water leaks, wiping down equipment to keep dust, dirt, and other debris at an absolute minimum. If we have equipment operators on station for an entire shift and taking on these low-level maintenance tasks that may already be assigned to the maintenance department, one of the things that it does, it puts more time back in the pocket of the maintenance department and the individual technicians to be assigned more complex maintenance. So the low-level stuff is important. It needs to be done. But if we have people on site at the beginning or the end of the shift as they operate their equipment on say, on a production line, we could take advantage of that opportunity to complete more maintenance. I use visual controls in my facilities. Visual controls is it's a key that we use to put information on equipment, something as simple as labeling a gauge, or if a certain condition exists on a piece of equipment, to change a filter. Or we use the stoplight colors, is what I call them, red, yellow, and green, to initiate an intuitive response from an operator or even a passerby. Someone out on the production floor sees a piece of equipment operating, an associated gauge is functioning in a red zone that's marked on a piece of, on a gauge, for example. Think about the tachometer on your automobile. If that needle on that gauge goes into the red, there is some concern for the equipment being damaged, and this is the training that we want to tap into. OEE is overall equipment effectiveness. That is a technique where you look at an individual piece of equipment, and I can't stress that enough. We're looking at individual pieces of equipment and how they perform over time. It looks at availability of that equipment, the productivity while that equipment is operating. Let's say it's supposed to produce 60 widgets a minute and it's only producing 45. That's the productivity issue. And then, of course, the quality of that product. You take those values, which is usually expressed in a percentage, multiply them together, and that is your OEE. 5S techniques is a tool that we use to help streamline processes in the maintenance department. Primarily that is through some organizational efforts so we can get parts, tools, test equipment, technical information into the hands of technicians more quickly. Again, if we can put more time in the hands of technicians on a given 40-hour work week, we can ask them to use that time productively so we can get more maintenance completed in a given week. We do discuss preventive maintenance opportunities, predictive maintenance tools such as infrared, ultrasound, vibration, oil analysis. Some organizations even use a fifth one, which would be destructive testing and evaluating pieces of equipment that have gone off site to be overhauled, for example, to gather information on what may have caused that particular piece of equipment to fail. CMMS, computer-based maintenance management systems. CMMS is a wonderful tool, particularly if you have a large inventory of assets in your building. It doesn't matter if you're a healthcare facility, manufacturing, or education. The equipment that you have responsibility for, a CMMS system is the best way to organize maintenance, issue work orders, issue PMs. Those are checklists that essentially help people remember what needs to be done in what sequence. People don't have to rely on their memories, and it helps keep people safe and out of trouble and helps prevent equipment from being inadvertently damaged or certain steps being forgotten. CMMS is not a prerequisite for success. There's many organizations out there that don't use a CMMS program, but it is a common thread that runs through the most successful programs. Reliability-centered maintenance is a term some of you may not be familiar with, but it is the application of preventive maintenance, predictive maintenance, planning and scheduling tools, again, to streamline our processes and make sure that they're the most effective, the use of a CMMS program, and gathering equipment performance data over time. And I'm talking about somewhere between 3 and 5 years to be able to track and gauge how individual components are performing out in your facility. And if you start to see particular pieces of equipment fail on a regular basis, you know, if it's a fleet vehicle, maybe you have a starter solenoid that wears out at 72,000 miles. We could write a PM close to that 72,000 mile window so we could ensure that we get maximum use of that component, but we replace it before that component fails, and we run into the cost of retrieving that vehicle, say with a tow truck, and having to send it to a garage and wait its turn to be evaluated and the part replaced. We're trying to be as proactive as we can so we don't lose access to critical equipment, and we can keep it in a production mode or a service mode as long as we can. I talk about specific tools and methodologies. Most importantly, the predictive maintenance tools, infrared, ultrasound, vibration, oil analysis, how we can use planning and scheduling and evaluate our critical equipment so we can bring the right technology to play. I've had many classes where people have come to talk about predictive maintenance, and they're very, very excited about the tools that they've already purchased. But they've kind of gotten ahead of themselves because they haven't identified critical equipment and what problems they may be suffering with when it comes to their critical equipment. We need to make sure that the technicians and management understand that the predictive maintenance tools are just that. They are a resource that we can use once we've identified our problems. I don't want to have someone invest $50,000 in predictive maintenance tools and programming and not identify what their problem is. We need to find the problems first and then apply the technology. One of the things that I do enjoy so much about these courses, people have an opportunity to share information. They're a wonderful networking opportunity. People have a chance to come in and share with one another, say what has worked in their facility and what has not worked. On more than one occasion, I've had someone come in that to attend a class that is wrestling with a problem at their facility, and someone in the same class has been able to help them. They have identified some solutions to the same problem in their facility. So every now and again, it's just a perfect combination. A little Hoosier wisdom here. This is Kurt Vonnegut. He grew up in the same hometown I did. He's got a library just off the circle in downtown Indianapolis. He wasn't a technician. He wasn't a businessman, but he did have a great insight into human character. And this is my favorite maintenance-related quote. Everybody wants to build, and nobody wants to do maintenance. Unfortunately, many of the people that we deal with at work don't understand the capability of the maintenance department, what maintenance can do, what maintenance can't do. There are certain things that maintenance is often called upon to do that pulls people away from their primary responsibilities. And that, of course, is conducting preventive and predictive maintenance to maintain plant capacity. It's not the job of maintenance to fix things. Maintenance needs to focus on availability, productivity, and the quality of the product and service that we're providing. The reason I put this slide in my presentations is I think it's important for maintenance to take on kind of a coaching, a mentoring approach to senior staff, operations, people in our own maintenance department, and help people better understand what the proper role and focus of the maintenance department should be. I like to have objectives to all my classes. This is Mr. Nakajima. He was very, very prominent in Japan as part of Toyota and their efforts to develop and drive lean management programs. This is a quote from his obituary that I thought was particularly interesting because Mr. Nakajima actually regrets TPM being looked at as a maintenance department activity. It really is a total facility supported program. In a nutshell, if maintenance is the sole responsibility of the maintenance department, we're doomed to failure. We really need to draw on the energy and the expertise and the experience of all the departments that have a thumbprint on our production equipment, and that will include operations, the safety manager, the plant engineer, even the purchasing director has a role to play. And if you're in a union facility, we do need input and cooperation from the union in order to maximize our plant's productivity. So TPM stands for Total Productive Manufacturing. We do stress the key elements of TPM, the correct application of preventive and predictive maintenance tools, planning and scheduling techniques. I've included storeroom controls here because I believe the warehouse, the parts crib, is the beating heart of any maintenance program. We have to be very selective and supportive of the people that we have in the crib. They have not only a huge financial responsibility. I was in Louisiana earlier this year at an international paper facility. They had $40 million in repair parts at that facility. That's the largest number that I've heard in several years in teaching these programs. I mentioned autonomous maintenance. Get our operators engaged. There is a great opportunity here to provide additional time for our maintenance staff and at the same time develop that sense of ownership and urgency in our equipment operators. Root cause analysis is an excellent tool that we develop in our courses. Root cause gives you the tools to look at an existing piece of equipment, identify and force rank problems so we can focus our efforts to improve the productivity of that piece of equipment. Essentially, we're looking over our shoulders. We're looking at the equipment from a historic perspective. And this, again, requires inputs from our subject matter experts, both inside and outside of the maintenance department. If we have a piece of gear that we have quality issues, breakdowns, excessive overheating, vibration, raw materials are inconsistent. There's a lot of different problems that need to be discussed, and they can't be resolved purely from a maintenance perspective. So we get our people together, our root cause analysis team, our subject matter experts, and there's certain diagramming exercises that we can use to help identify, force rank, and then focus on improving those issues that are within our control. Training for maintenance staff as well as equipment operators, warehouse staff is very important. I haven't been in a facility in many years that has been able to say, well, we routinely train and test our equipment operators. How do you properly bring a piece of production equipment online? How do you stabilize its performance? What is the normal sequence for shutting the equipment down? So a practical exam and a written exam is important because we need to know what their skill levels are and the amount of knowledge that they have to the equipment that they're operating. Because if there's an issue, we need to take steps to fill that knowledge gap. So again, the equipment is properly operated. There may be people at your facility that have not received adequate training. They're cutting corners. They've been not well trained. It's not like they're disgruntled employees, not at all. They just haven't had the training that they need, and sometimes those knowledge gaps result in issues that are reflected in the equipment. The last bullet here on design excellence is a very important concept inside the maintenance department and outside the maintenance department when it comes to standardized equipment, purchasing of spare parts, raw materials, but most importantly, when it comes to excellence in design, we need to be reminded that reliability is a function of design. This is the a magazine called Uptime Magazine. It's for maintenance, reliability, and asset management professionals. In my personal and professional opinion, this is one of the best written magazines in North America on maintenance, and it has a very interesting cover story on this one where it says that maintenance is not really the problem. What we're looking in many facilities is that we have equipment that is poorly designed. It has flaws associated with the design. It may have not been properly installed. We have operators that are operating that equipment that haven't been properly trained. We have technicians that have not received the right test equipment. They don't have adequate spare parts. They don't have technical publications at their fingertips. So they're very limited and also in getting access to that equipment to conduct maintenance. Mostly what they do is reactive maintenance. So we have all these issues day after day, as well as situations where you have undocumented, uncontrolled changes, modifications that haven't been recorded and reflected in up-to-date line drawings. All this has a very negative impact on the productivity of our equipment, and it limits maintenance to only being able to maintain the inherent reliability in a piece of equipment. If you have a poorly designed piece of equipment, we cannot hope to have world-class productivity if we begin with a very poor design and these other issues that I've mentioned. Several times in the classes that I teach, I touch base on Dr. W. Edwards Deming. Dr. Deming is considered the father of the American quality revolution. He's a scientist and an engineer. He established his professional credentials before World War II. He's since passed away. But this is a picture of Dr. Deming late in his life and the Deming Prize. Dr. Deming went to Japan after World War II and took his principles and his information, his knowledge of nearly 40 years in industry at that point, and was a key player in the resurrection of Japanese industry after World War II. Much of their focus in the 40s, 50s paralleled the thoughts of Dr. Deming. Dr. Deming focused on quality. His comment was, quality tends to, if you focus on quality at a facility or at a company, if you focus on quality, quality tends to increase and costs will fall over time. And the Japanese took this to heart. And when you think about what Japan was able to do from the end of World War II to the beginning of the 1970s, they were a country that was terribly devastated by the war. And 25 years later, they were the second largest economy on the planet. Dr. Deming later came to Detroit, Michigan, and had a similar impact on the United States automobile industry. Here's a quote from Bob Williamson. Bob is a contributing editor to Maintenance Technology magazine. He's a very, very well-known consultant in the maintenance industry, and I really like his definition. He's looking at critical equipment from the standpoint of business goals. What equipment must we have available to meet our business goals? And he places that equipment in what he has called very eloquently the maintenance fast lane. We're going to focus on that critical equipment. We're not going to defer maintenance on that critical equipment. And I usually recommend that critical maintenance be scheduled early in the week. So if you have a problem or you need a part or you have to bring in some technical expertise, you can still get it done within that work week. As you focus on critical equipment, that equipment's performance is going to be enhanced, and we use any free time made available as performance improves to do more planned, preventive, and predictive maintenance. I know many organizations can only get 2 or 3 PMs per technician done every day. This will enhance not only the performance level of our critical equipment, but management can now focus on scheduling and conducting additional PMs. So it's sort of a snowball effect. Planning and scheduling, in a nutshell, the planning, the what, how, and where of conducting preventive maintenance. We've got to it's very important for people to put written PMs in the hands of our technicians. Written PMs helps make sure that people are aware of safety issues. They understand the precautions that they're obligated to follow along the lines of NFPA 70E. We can list all the PPE, all the parts, the tools, the technical diagrams that they need. If there's any special requirements such as lockout, tagout, or confined space, tools, all of these things need to be satisfied before a technician goes out on the floor to conduct maintenance. The scheduling piece, the scheduler is looking at who is the best person to do this job. Do we have a pool of people that can do this rather simple task, or is a certain qualification required in order to do that, such as an HVAC tech having a 608 card so they can actually store and use refrigerants. These jobs are all impacted by priority. Is it a critical piece of equipment? We're going to try to do our maintenance around production schedules. We need to cooperate with operations so that scheduled downtime is not a huge interruption on productivity, because we all know that if you're working in a manufacturing facility, meeting production goal is very important and is very much on everyone's mind. Labor assignments, who's going to be doing the work, the specific date of the week, and the time would be what shift. The next diagram here is a work process flow diagram that I go through in my classes to literally lay out how we validate a request, how we approve a work request, how those particular approved requests go through a planning and a scheduling review. So again, do we have the right people with the right tools, the right training? Is this a qualified technician to go out and conduct the PMs? There are spot check opportunities to make sure that our people are following the requirements for PPM and that we're getting a proper PM done. I really can't emphasize that enough. I think it's great to do spot checks, because that way our people know that this is just not another piece of paper that's going to disappear in a file somewhere. So there is a process flow associated with planning, scheduling, and conducting preventive and predictive maintenance. Oh, here's just a quick review here on these visual controls when it comes to marking gauges or putting additional information on equipment where it can best be utilized. Again, this is not a labeling exercise. What we're doing is looking at putting information on or near equipment to improve the operation of that piece of equipment, help the maintenance process, and provide information more quickly and more clearly to our technicians and operators. I like to use the stoplight colors because it initiates an intuitive response. It triggers a response, and it can help us maintain and operate our equipment more effectively and more safely. We do have several exercises on 5S implementation. These are the Japanese cuneiform, the translation into our alphabet, and then translated into English. 5S is not just Brett's excuse for cleaning up the shop on Friday. There's a much more to it. It is actually a philosophy and an organization tool, so we can look at our warehouses, our work areas, the production floor, what have you, in an effort to become more safe and better organized. Nothing is as frustrating as having to go into the warehouse and you're looking for a part that you may have seen last week and now you can't find it. You can't put your hands on it. We want to be able to streamline these preliminary steps in a maintenance process so we don't have parts related downtime. So this is a great tool. It's very easy to coach. It's very easy to train and oversee. Again, in an effort to organize and clean up workspaces so that we're not wasting time and climbing over parts and other pieces of equipment to get our hands on the tools and information that we need. You guys may remember Clara Peller. This picture of this little old lady here, she's the lady that used to work for Wendy's, and her catchphrase for those commercials was, "Where's the beef? Where's the beef?" This is the little old lady that I want on my root cause analysis team, because she's going to focus on the process. What's wrong with the equipment? She has no political axe to grind. She is not interested in that smoking gun mentality where we're looking for someone to blame. We're looking at our processes, because most of the issues with equipment on the production floor have to do with processes that have broken down. So we're going to stay focused on what happened, how it happened, and why it happened, because we do not want that to happen again. There's a 5Y tool that can be utilized. This is a great tool for technicians to help think outside the box. That's why I put this box on the slide. Oftentimes, technicians fall back on troubleshooting and preventive maintenance completions. There are other issues that may not be answered by those two items, so we have to put additional tools in the hands of our staff to help them think outside the box. This is Dr. Ishikawa. He was a colleague of Dr. Deming's in Japan in the 50s and 60s. He also focused on quality, and he's the first man to put pen to paper on what he called the cause and effect diagram. This is just a visual brainstorming tool, and if you look at this tool, you can see why it was called the fishbone diagram when it came to the United States. Here's the head of the fish, the spine, going back horizontally, and then there's 6 areas here of evaluation processes that form the ribs to the backbone: measurement, human manpower, machines, environment, I call that Mother Nature. We've got materials and processes or methodologies. Again, Dr. Ishikawa focused on quality, and his thought was, if we have a piece of equipment that isn't living up to our expectations, we can't get rid of it, we can't replace it, what do we need to do to boost the productivity of that piece of equipment? So in these 6 areas of evaluation, we're going to start listing what our problems are. For example, here in the human side, we've got inadequate training of our equipment operators. They may have poor supervision as well. We can identify those issues, we can force rank them, and if they're high enough on the list, we can start to dedicate time, money, and effort to either minimize or hopefully eliminate those problems. So everything we do on the left side of the diagram to reduce our problems is going to increase the quality of that product or service in the performance of that piece of equipment. OEE, as I mentioned before, is a very valuable tool when you're evaluating individual pieces of equipment. There are 6 big losses that we look at in my classes. Some organizations have as many as 10 or 15, but these are the 6 common ones. We're looking at availability losses, such as a piece of equipment breaks down, or there's a time where the equipment is not operating, say between shifts, or installing a new die in a machine. Performance losses could be equipment operating at reduced speed, or you've got a blockage somewhere on the production line. So that piece of equipment isn't operating until that blockage is cleared. Quality losses, maybe we have material that comes down the production line and it's defective, and you have to send it to a rework facility within the plant to restore its quality before you can sell it to a client. So those are all evaluated. We discuss them in the various facilities where our students are coming from. The idea is to look at an individual piece of equipment and what do we need to do to optimize or improve its overall equipment effectiveness. The numbers are indicative of what we do, but the bottom line here is what additional funds this piece of equipment provide if we improve its capability. The OEE is just a tool. What we're really looking forward what we're really looking to in this type of process is getting more productivity out of our equipment in the same amount of time, so our profits would go up. Inventory control, as I mentioned before, it can involve tens of millions of dollars. It's an art and a science. We look at spare parts management, reorder point, economic order quantity. Those are what these two abbreviations stand for. And the minimum number of parts of a certain type that we need, and what that maximum number needs to be, say, for us to operate for a calendar quarter or month to month. This is a major issue. It involves quite a bit of funding. And again, if we don't have what we need in the warehouse in the identifying the right parts or the right quantity, we can suffer what I call parts-related downtime. So this is an issue that we don't put any small time into. I actually lead a course in inventory management because, like I said, this is the beating heart of the maintenance process. We look at dollars on hand. Like I said, these inventories are very valuable. We're looking at what we need to do to keep the equipment up and running online, what numbers those represent, and what's the lead time to ordering parts. So when our inventory starts to drop down to a very low level, we have spare parts arriving on the loading dock. Advanced preventive maintenance systems in their warehouses actually have the ability to prepare kits for scheduled maintenance, such as during a stand down, a semi-annual or an annual check. Parts come in, they're segregated from the main inventory in the warehouse. So when the shutdown starts, all the parts that are needed for that complex piece of maintenance are available to the technician. It keeps the technicians out of the warehouse and keeps them on the production floor. Barcodes and QC. Barcoding is a very advanced technology. Believe it or not, barcoding has been used in industry for over 50 years now. Ask yourself this question: when was the last time you went to a retail facility and your purchase wasn't barcoded? It's been a long time for me too. QC coding is another coding identification tool. It was developed in Japan in the mid-90s. They use that. We're using that today in a lot of manufacturing processes. The QC coding is a little different from the barcoding. It looks like those little squares on a tag that you can see on a piece of equipment, say at an industrial warehouse. It contains significantly more information than a barcode. So it's same principle, but advanced technology. Safety issues and compliance issues as it involves either OSHA or MSHA. MSHA is the Mine Safety and Health Administration. There's been many, many significant changes over the years, over the last 10 years, let's say, where now the Department of Labor is cooperating with other federal agencies, such as the Department of Justice, the FBI, and the Treasury Department. We're seeing more and more individual responsibilities if senior management is involved in criminal activity to avoid reporting safety violations, discouraging their employees from participating in union activities, and by not repairing these problems or addressing these issues, they're they're falsely reporting the financial status of the company. And that's why the Treasury, the Office of the Inspector General, and the FBI are now more involved in these type of criminal investigations. So there's been a significant shift here since 2010, and we do get into some detail on that. Mobile technology has made huge advancements over the last couple of years. I attended the National Facilities Maintenance and Technology Conference in Baltimore this past March. They hold 2 a year, one in the spring in Baltimore and then a second usually in November. In the last couple of years, it's been in Fort Lauderdale. No, that's not right. It's been in Orlando. It's a great opportunity to look at technology as well as attend some training seminars. One of the things that really came out very, very clearly this year was it's really no longer a question if you're going to be using mobile technology, it's really when. The opportunity for us to put the entire equipment history on a piece of production equipment in the hands of the technician while they're out in the field, while they're preparing to do maintenance or do a corrective, just cannot be overemphasized. Netbooks and notebooks are becoming so very affordable now. The netbook on the left-hand side of the screen, you could pick something like that up at Best Buy, a Target, a Radio Shack if you can find one. Those are less than $150. They're literally a throwaway item. They're all XP, so they'll run any software in the inventory. They're 4G capable. It's a tremendous tool to connect people, technicians working in the field with the CMMS database and their supervisors so they can make real-time decisions conducting maintenance away from the main facility. We talk about vibration, oil analysis, infrared, and ultrasound. Like I said, this is just a pictographic showing here of what's called the PF curve, the potential failure curve, where we have a piece of equipment that is operating and then it starts to degrade. And you can see the stoplight colors: green, yellow, orange, and red, red representing function failure. But as the equipment continues to degrade over time, you can see the timeline here of the various technologies that can be applied to give people a heads up that the equipment is starting to fail. This is probably the most significant tool about these 4 predictive maintenance tools. It allows us to recognize a problem, and it also gives us a timeline for us to make adjustments or take the equipment offline to do a full-blown PM or some type of repair action to get ahead of these failures. You don't have to drive the equipment into the ground. It doesn't have to run to function failure. And that applies to every technique here that we're talking about, whether it's vibration analysis, oil analysis, infrared, or ultrasound. Tremendous opportunities. Again, once we identify critical equipment, we can determine what our principal issues are, and then we can apply the right technology. I do an exercise that I call the cost of failures. I go around classrooms and I ask people what their critical equipment is. When it fails, what's the mode of failure? Is it mechanical or electrical? The last time it went down, what did it cost? And how many times a year do you see this? And are they currently using a predictive maintenance tool, or is a predictive maintenance tool, would it be something that we could apply? This type of exercise really snaps people's heads back. Whether you're doing it in a work center or you're doing it at a manager's meeting, the cost and the frequency of these failures is often is something not everyone knows, because something breaks on a Saturday night and they fix it on a Sunday. People come back to the facility on Monday and in their eyes, nothing changed. This is a great way to convey the seriousness of equipment downtime and what those dollar signs really are. Return on investment is an important topic because we have to justify purchasing these services or bringing new equipment on site. I like to look at that from the perspective of an attorney going in front of a judge and jury and arguing their case. for their client. We are talking about, again, a higher level, an appreciation for the finance side of our business, and this competitiveness for scarce capital funds goes on every day. So this is a topic that needs to be discussed. On the bright side here, application of preventive and predictive maintenance can lead to significant reductions in your energy bill. Please remember that your two largest overheads are energy and labor. And if we can apply preventive maintenance methodology followed by predictive maintenance technology, you can see from the quote from this DOE publication, we're looking somewhere between 20 and 30% in reduced energy costs. I can speak from experience. I applied a predictive maintenance program that involved infrared and ultrasound at one of my facilities. And after spending about $5,000 on that survey, my vendor identified approximately $235,000 in energy savings over the next calendar year if we repaired the issues that were identified during that survey. So I want everybody to understand there's a lot of money on the table when it comes to preventive and predictive maintenance operations. Communication is a problem. I do recommend that organizations meet formally at least once a week for like 45 minutes to discuss critical maintenance. We want upper management and people outside the maintenance department to understand what the actual condition of critical equipment is and the need to conduct maintenance. This is not a place where we're going to talk about daily and weekly checks. Focus on critical equipment. We get all the decision makers in a room to make an inclusive decision. We brought our subject matter experts together in the same room for 45 minutes to lay out what the focus of the maintenance activity in that plant needs to be in that next week. And the guy that's the most responsible for this, the individual, the man or the woman, is the plant manager. It is not the maintenance program. It is the plant's preventive and predictive maintenance program. We talk about the pillars of total productive management. And again, starting with our 5S foundation, we talk about PMs, autonomous maintenance, training and education. That is all key to developing a world-class program. And this is kind of like my version of Dr. Ishikawa's diagram. If we can maximize these issues on the left side of the graph, we're going to see higher levels of equipment reliability, availability, improved quality in our product and service, and that will lead to higher sales, higher percentages of our product being looked at and purchased in the marketplace, and that's what keeps businesses in business and keeps people like us employed. A quote from Mr. Foltz from the Marshall Institute, TPM, again, it's a tool to help us increase equipment reliability. If you apply these kinds of tools and technologies and you're able to prevent a catastrophic failure to a piece of critical equipment sometime in the near future, there is no doubt in my mind that those critical failures that are avoided will easily pay for the cost involved in instituting these programs, training your people, maybe working with the vendor. The opportunities there are just so significant. We'll focus on safety. We need to figure out where we need to go with these programs, what's our critical equipment, what our goals are, how we're going to approach those, and in very little time, measured in months, total productive manufacturing, 5S, planning, scheduling, inventory management, predictive maintenance activities, those can all become core business processes at your facilities. Goals, like I said, critical equipment, autonomous maintenance, OEE, and eliminating parts-related downtime. Final quote here, this is a picture of Admiral Rickover. He was the father of the nuclear navy. He built the first civilian reactor in the United States and launched the Nautilus. I had the honor of meeting this gentleman as a young midshipman in 1977. And I really like this quote. Good ideas must be driven to practice with courageous patience. This is not an overnight turnkey operation. We can start working these kinds of issues in your individual work centers, graduate to your departments, and after these ideas prove themselves in the facility, these can quickly become a facility-wide program and objective. So never give up. Be patient. Stick with what you know. Again, we're here to help. John, back to you, sir.
All right, thanks, Brett. At this point, we'll start taking some questions. So if you have any questions, please type them into the box on the panel on the right side of your screen there, and we'll start taking some of your questions. I understand we really just glossed the surface of this, Brad, as I'm sure you know. And TPC Tranco does offer a variety of two-day seminars that go into much more depth on these topics. But we wanted to give you sort of a high-level view to kind of get the thought process going about, how you can make maintenance and effective maintenance a bigger part of your facility. So with that being said, we'll start taking some questions. Oh, and one other housekeeping item, of course, is if you need a copy of the presentation, please respond to the email that you will get at the conclusion of the presentation. Just respond to that email with a request for that copy of the presentation, and I'll get that right out to you. So, Brett.
Yes, sir.
If you had to choose, what is more important, the planning or the scheduling? Or is that really like picking your favorite child?
It's more like picking your favorite child. Some organizations that are so large and have to have such tight control, say they have a large number of technicians or their particular facility operates 24/7, that drives whether you're going to have a planning group or a scheduling group. If you have a smaller facility, say that has in the neighborhood of 20 to 25 technicians, the planner scheduler role usually can be handled by one individual. But it's like washing your hands. You need both hands to do that.
Okay. One question we got, though, is whether or not this presentation will actually be archived. So I'll actually take that one, Brett. Yes, we are recording this presentation, and it will be available probably Monday, at the very latest Tuesday, up on the TPC Tranco YouTube site. So we'll have that available for you in its entirety up on our YouTube site for you. Now, Brett, can you provide just a bit more detail than you were able to about the different steps of 5S? We got a question asking for just a little bit more detail about those 5 steps.
The 5S steps, they're not prioritized. They are, as far as impact goes, unfortunately, most people focus on the shine piece, but if it were me, shine would be at the bottom of that list if I was force ranking it. The 5S, starting with the sort piece, you're going through your warehouse, your parts crib, your workshops, and you're determining what you must retain, and if there are items that you don't use anymore, then we need to get those out of those workspaces so people can work more easily, more efficiently, and find what they need. Along those steps, let me think about the other ones. The sort, and then the I'm having a brain rock here. The detail in these following steps really involves prioritization. We've got this. I'm sorry, I'm just drawing a blank here. Let me go back and be able to read those real quick, because I don't want to avoid this. I do apologize. I just kind of blanked out here. Let me go back to that and see if I can get more information. Oh, darn. John, I'm going to ask you to go to the next question, and we can come back to that, please.
Yeah. Do you have any recommendations for implementing the practices that we've been discussing today for a small business that only has 2 maintenance techs? So basically implementing effective maintenance on a smaller scale.
If you're going to be establishing maintenance on a smaller scale, you may not, obviously the planner scheduler piece may appear to be overkill, but one of the things I think is important is putting, say, a basic checklist on equipment. So that if you're doing certain things on a shift basis, a daily basis, weeklies, monthlies, if you can take that kind of information and put it on a simple checklist that can be, let's say, laminated and stored next to a piece of equipment, operators, maintainers, they can review those lists. Essentially, they've got a PM in their hand. What do they need to look at? What fluid level they need to confirm? Make any kind of adjustments. This way, you don't rely on just their memory and their experience. It helps people so that they don't forget issues, they don't forget steps. That is one of the common ways that I've done it with particularly small, privately owned businesses like a welding company or people doing automotive work. We don't need a full-blown maintenance program, but we don't want them to be missing steps and maybe putting themselves in jeopardy or affecting the equipment.
All right. Brett, while you find the 5S slide, I'm actually going to answer the next question because one of our attendees asked the question if we provide training via webinar. And the basic answer to that is yes, we offer what we call an online simulcast. And what we do is we take one of our normal 2-day public seminar training classes and we basically broadcast it over the internet. So if for whatever reason your schedule doesn't allow you to head out to a city to view a specific seminar or to leave your facility at all, some of our seminars are broadcast over the internet. It is not a recording, and it is not just something that you do on a computer. It is an actual live seminar that you can participate in. You will have all of the same materials that anybody in a live instructor-led classroom would have. You would have all the same chances to interact with the instructor that those people have. They can interact with you. It is entirely live, but it is just something that we broadcast online for folks that simply can't always get out of the facility to attend a public seminar. You can find information on that for a specific seminar on our website at tpctrainco.com. So, Brett, do you want to revisit the 5S?
Yeah, the sort piece. Again, looking at the items that have been on a shelf for a particularly long period of time. Maybe you've replaced a piece of equipment and you're not using those parts anymore. First time I did that at the University of Central Missouri, we found $35,000 in the parts we weren't even going to be using anymore. The shine piece, the shine is basic cleaning. I'm not interested in having floors so clean that I can eat off them, but I want the dust and the debris removed so the floor's not as is not slick and potentially a slip and fall hazard. I like to have the horizontal surfaces cleaned and the motors and the pumps covered so that they're not being contaminated by dust. The most significant thing you can do in a shine scenario is lighting, because if a space is dark, it looks dirty no matter how much time and effort you put into it. The storing phase to it, I want my warehouse to look like Home Depot. Instead of having pumps and motors and cables and belts and filters just stuck away randomly in different cubby holes, I want 8 rows of mechanical, 10 rows of electrical, 4 rows of plumbing. I built paint booths, welding shops, to get that facility so organized that people can go into the warehouse and it's one stop shopping. They don't have to continue to look because, well, the part was here last month, it was over here last week. You go into the warehouse, you go to the area where it should be stored. If it's not there, you stop and you order the part. Far and away too many technicians are spending several hours every day in the warehouse or parts crib looking for tools, technical information, and spare parts. The next step was the standardize. I'm not a big fan of change for change sake. Some people have to, sometimes they think they want to make a big splash in an organization, so we're going to change some things. Well, that's not really the idea. The standardized piece usually is driven by one of two factors, which would be finances or safety. So if you have to change the way you've been doing something because it will save us money or is particularly a dangerous operation, we figured out a better way to do it, then we're going to have a new standard. And we need to train people to that standard. We can take input from them as part of that training, and if necessary, we need to publish what that new standard is so everybody knows what their new obligation is in relation to that standard. And the last one is probably the most difficult of the five, and that is sustain. There is a tendency in human nature, if we don't train people to this new standard and hold them accountable, they tend to fall back to the old way of doing business. And again, this could become expensive and it may even be dangerous. And we need to have not just new people joining the organization going to this kind of training as part of our sustaining effort, but senior staff, tenured staff need to go there so they can provide their input and their support to what that new standard is. And if down the line we come up something different and we change it again, or we go back to our old standard because what we thought was going to be doable is not, then we can change that too. None of these rules are written in stone. They're constantly under evaluation as part of our commitment to continuous improvement.
All right, thanks, Brett. We have time for one or two more. This next question comes from a school maintenance team, and they're asking, how often as a school maintenance team should we have a cost of failures meeting? Is there sort of a general rule of thumb in that respect, Brett?
It's really not a rule of thumb. This is mainly part of a training exercise to help raise people's level of awareness. But there is nothing that says if you have an equipment fail, to share the information about that failure. I've talked to a lot of people, they know that a piece of equipment goes down, but when you start to calculate and gather information as to why this actually happened and the cost of restoring that equipment, such as loss of productivity, when that equipment is down, it's not producing our product or service. What does that represent in dollars? You have parts that you may have to order, and if you have to drop ship them overnight, that can be very expensive. Let's capture that information as well. Overtime for bringing people in to work and correcting that problem. Maybe you're sending equipment out to be repaired by another shop because you don't have that skill set in-house. All that financial data can be gathered to put a dollar sign on what that actual casualty cost us. And that, I think, is another driving factor in helping people better understand the emphasis that we need to put on maintenance, because studies have shown that the cost to repair a piece of equipment is sometimes as high as 4 times the cost of conducting maintenance. Principally around that loss in productivity can be the most significant loss.
All right. Well, ladies and gentlemen, we have reached the end of our time slot here. We certainly want to be respectful of your time, and coincidentally, we've exhausted all of our questions. So on behalf of Brett and myself, I just want to thank you very much for taking your time today. If you do have any additional questions, please feel free to reach out to us. Again, I will provide any copies of materials that you need, and also an electronic copy of the presentation via YouTube if you needed to. Just please respond to the email that you'll get at the conclusion of this webinar. So thank you very much, ladies and gentlemen, and enjoy the rest of your day.